Good morning, ladies and gentlemen. Welcome to our course Mathematics B. In the previous semester, in Mathematics A, we discussed the basic notions of calculus, functions, derivative, integral, and some applications, Taylor polynomial, Newton's method, and so on. In Mathematics B, we are going to develop these notions for functions of more than one variable, two or more variables. My name is Pavel, Pokorný, and this is my email address. VSCHT is the abbreviation of the name of our university. In Czech, it is Vysoká škola chemicko-technologická v Praze, and in English, it is University of Chemistry and Technology, Prague, Czech Republic, Europe. Today we start with some notions like scalar, vector, and matrix. Some quantities in physics can be expressed perfectly just by giving a single real number. An example is mass, 5 kilograms, time, 2 seconds, density, and so on, temperature. While these quantities are called scalars, and in mathematics they are described by one number. We usually work with real numbers. One real number can be visualized as 1 point on a real line. On the other hand, some physical quantities must be specified by giving more information. An example is position, velocity, acceleration, force, intensity of electric field, intensity of gravitational field. And these quantities are called vectors. An example, a position in a plane can be specified by giving two coordinates, x and y. So instead of one real number, we need two or more real numbers. When we are in a plane, we are just happy with two numbers. When we are in a three-dimensional space, then to specify a point in a three-dimensional space, we need three numbers. In general, we can consider a vector A from Rn. R is the set of all real numbers, and Rn means the set of all n-tuples of real numbers, pairs, triples, or more. And then there are even more complicated structures, like a matrix. An example of a matrix may be like that, 2, 3, 5, 1, 0, 7. This is an example of a matrix which has 2 rows and 3 columns. And the individual entries of a matrix will be usually real numbers. Okay, let's go back to vectors. What operations we have for vectors? Well, even before operations, how can we denote, how can we write down a vector? So one possibility is to draw a little arrow above the letter, above the symbol. Other possibilities are to underscore the symbol. Other possibilities are to write it in boldface. This can be done in print, but it's not very useful for handwriting. And in some books, you can find a vector just by writing a letter with no special graphical distinction. We will usually use the arrow that comes from physics, meaning some direction, some orientation. And then if we have, say, a two-dimensional vector with two coordinates, two components, then we can write it either as a column vector or as a row vector. In some cases, this is a difference. For today, we will not distinguish between a row vector and a column vector. So I prefer column vector, so we can have a vector A, say with coordinates 2, 3, not to be confused with the combinational, with the combinatorial coefficient. This is not 2 above 3. This is a two-dimensional vector, just a point in a plane. And then we can multiply this, say, by 10. So 10 times the vector 2, 3 is the vector with coordinates 20, 30. Graphically, it means that if you have a vector like that, and you multiply the vector by a scalar that is greater than 1, then you make the vector longer. 10 times longer. In general, if we have the vector b, which is alpha times a, then if we denote the components of a as a1, a2, a3, and so on, and the components, the coordinates of b, b1, b2, b3, and so on, this means that bi is alpha times ai. Each component is multiplied by this number, by the scalar. So this is multiplication by a scalar. Another operation is addition of vectors. So if we have two vectors, say 5, 7, and 2, 1, we can add these vectors 5, 7 plus 2, 1. And the addition is simply defined component-wise. That means we sum the first components. 2 plus 5 plus 2 is 7, and 7 plus 1 is 8. In general, if C is A plus B, then the ith component of the result is just the sum of the corresponding components of the two vectors. And graphically, if we have a vector like that and another vector, then the sum of these two vectors can be graphically found by drawing this parallelogram. So this was basic operations with vectors, namely addition and multiplication by a scalar.